Hello everyone and welcome to this 22-minute webinar, Design to Manufacture, featuring SOLIDWORKS CAM 2018. My name is Allison Savell and I'll be your host for today. Let's jump right in and get started. Just a quick couple of housekeeping notes before we get started. First, using GoToWebinar, please notice the full screen button to move in and out of the full screen mode. We strongly suggest using full screen. If you have questions during the presentation, please enter them into the questions section, not the chat section. We'll answer these questions after the presentation concludes. Also, we will have several poll questions during the presentation to keep things interactive. We ask that you answer these multiple choice questions quickly, and we'll keep within the time frame, and I'll let everybody know the results of the poll. Please note that we are recording this session, and we will send this out post webinar likely tomorrow. So let's jump right in with our first poll question. Please pick the description that best matches your job do you perform. I'll give it a few minutes, a couple seconds. All right, close that. Share the results. Got about 22% of you are working on CAM. All right, we'll jump right into our second question. Please select the following that closely describes your company. All right. Share that out. All right, 48% of you are in design, assemblies, and manufacturing. Great. All right. So with that, let's jump right in with, let me introduce our rock star presenter today. With us, we have Mike Buckley, who's our Senior SolidWorks Portfolio Manager working in product management. Mike, it's all you.
Thank you. So first off, welcome everybody. We'll go through a few slides here, a little bit of explanation about what SolidWorks CAM is, and then we'll have a little bit of time at the end. We'll go over a little bit of a demo so you guys can see how our workflow happens inside of SolidWorks CAM. If you happen to attend the earlier webinars we did last month, you'll notice we've been sort of going through this process of design to manufacture. Today, obviously, we're going to be talking about the SolidWorks CAM portion, which happens between, our processes. We design it, we detail it, then we have to program it before we can get to like inspection, compose, or visualize, and actually shipping the part. So our focus today is going to be 100% on the SolidWorks CAM side and just sort of show how that interaction works. But please stay tuned. We have more webinars coming up in the future for things like inspection, composer. You'll even see some cool things, hopefully, for visualize that we're doing with AR, VR. So if you're interested in AR, VR stuff, definitely keep an eye on the website for some new visualize content coming out. So what is SolidWorks CAM? There's lots of things inside of messaging. You'll hear people talk and they'll say SolidWorks CAM is available in 2018 for everyone on subscription. That is true. However, there's a little bit of a discrepancy that I want to spend a little bit of time explaining this morning. So SolidWorks CAM standard is active if you're on subscription in 2018 SolidWorks. And what SolidWorks CAM standard allows you to do is it allows you to do 2.5-axis traditional milling style routines. Could also be used for laser, water jet, plasma in a part-only environment. So in a SolidWorks part-only. But you do get the ability to do tolerance-based machining where we can read MVD data and we can actually make decisions based upon that data. So that covers a little bit about what comes with subscription. Please keep in mind that SolidWorks CAM standard will work as long as your subscription is active. So it's one of the value add to subscription service with SolidWorks. And then if you're looking for a little bit more function, and what that does is that actually takes everything that's in CAM standard and then adds the ability to do CAM configurations that tie to your SolidWorks configurations. You can do assembly machining. So if you were doing, a vise and a fixture, you were using partner product like nesting works, where you're automatically nesting out a group of parts. You can then put tool paths on those in the assembly environment. High-speed machining through volume mill, which is what we use for all our 2.5 axis high-speed machining routines. Basic turning, no live tooling. So if you're just doing more like a standard Haas SL20 and you're just doing basic tooling paths like what would be a revolve feature, that's covered. And then 3+2 machining, which is indexing or pre-positioning on 4 and 5 axis machines. So if you're looking at like a trunnion and a rotation on a Haas, you would be able to control those axes inside of SOLIDWORKS CAM Pro. Please keep in mind that SOLIDWORKS CAM Standard and Professional was released in 2018 in all 14 languages. So the same languages you have in SOLIDWORKS are the same languages you'll get in SOLIDWORKS CAM. So one of the things I do want to share this morning is 3+2 machining, because there are lots of questions that come around 3+2 machining. So we have this little video that we took from YouTube, which covers a Haas with a 5-axis machine. And what 3+2 machining is the part rotates to a position in 4 and 5 axes, and then we actually run the tool path. So we're not simultaneously moving the machine or the 4 and 5 axis around like you would do on a turbine blade. We're positioning to a location, and then we actually do the machining as it relates. So in 3+2, we are controlling all 4 and 5 axes, but we're only running simultaneous 2.5 axis routines. Believe it or not, a lot of people use 4 and 5 axis machines today in this aspect or configuration, because it allows them to save time in fixturing and setup, and then also create a part with a tighter tolerance, because you're not using the human interaction to move that part around in different setups. So just to give everyone a little bit of a clarification of what we're talking about when we talk about 3+2, this is a quick example of that video and how that actually looks. So with that, we'll jump to our third poll question.
All right, we'll launch that. So how many of you use my SolidWorks? All right, we'll give it. All right, interesting. Pretty even across the board, Mike.
That's good.
Yeah.
We like to see it when it all comes out pretty even. So with that, let's jump over to a quick presentation that we have on just an overview of how SOLIDWORKS CAM works. We'll be taking a look at SOLIDWORKS CAM Pro today, so we'll be looking at assembly machining. So let me jump into SOLIDWORKS. And we're going to start with a Kurt Weiss here. Now, due to bandwidth and streaming capabilities, this will be a really quick overview just to give you guys an idea of how this process and workflow happens. Okay, so we have a Kurt Weiss here. This is the Kurt Weiss that I use in my machine in my shop. I use this for all my programming and assembly setup and environment. But just to give you guys an idea of how SOLIDWORKS can be used in the manufacturing environment along with SOLIDWORKS CAM, we're going to go ahead and we'll drop a part in this vise here. So we'll just go over to our design library, place I like to store my standard projects I'm working on. We'll pick a configuration to use here. And we just have this part that we want to machine in our vise. So the first thing we do is we use the best-in-class tools from SOLIDWORKS. We go ahead and we actually put some mates and we use some planes to do our setup. The nice thing about having these assembly files set in SOLIDWORKS is I have the ability to define a standard setup. So because I use this vise over and over and over in my shop, I have some predefined setups of where I want the bottom of the part to be, where I want my work offsets to be. So I can just focus on placing the part and doing the programming component of this. So we'll look at the top view. We'll move this guy up here. We'll just do a quick, we'll make that parallel. That way it looks a little bit closer to what we would actually machine. And you'll notice in here, I actually have a 3D sketch that controls my bounding box of what my stock would look like. One of the cool things about using SOLIDWORKS for programming and for machining is the fact that I can create macros. And there's a macro here that I have for auto size stock. And by the way, you can find all these macros in 3D Content Central. You just go into 3D Content Central, you search for John Milbury as the name, and you'll find all these macros that we're using. These are ones we've developed to make programming easier in SOLIDWORKS CAM. And as I click that, what it does is it creates a bounding box around the part and then auto sizes my stock and adjusts my vise to fit that part. So I can very quickly see where my part is going to fit in the vise and how the stock is going to fit around it. Again, this works great for visualization, but it also is a real quick check to tell me what the standard stock size is. Through the macro, we have some definition where we can set the tolerance, so it's always going to round up to the half or quarter or 3/8, so that way the stock is a nominal number, not just a random size that you can't order from anybody. So once we have that stock set, for this example, I'm just going to go ahead and fix this. And now we have our parts set in the vise. From here, we have all the cool things we could do. We can pull up a drawing that I have set for this standard, which gives me my setup sheet capabilities. So you can see I have an exploded view. All of my information is here. We pull in all the custom components based upon the part that was dropped in. So you can see now I have the ability to explain to someone how to actually go and machine this part. And again, we're just leveraging all the cool things that we do in SOLIDWORKS. For the CAM side, we just pop over. We tell SOLIDWORKS CAM that I want to machine this part. If we want to use a coordinate system, we can define a coordinate system. As you can see here, I have my work offset for a 54 on the back corner. I could move this visual aid anywhere that I want. I have this set up as a default in my assembly. So now I have my work offset defined. For stock, we'll just use my 3D sketch. So we'll just come in here and we'll say that I want to use that. And I want it to go up to a reference plane that's defined in my macro. And now my stock is defined so I know what to machine from. And if I make changes or updates, everything updates along with it. So from here, we're going to run through, we'll just use some quick feature recognition on this due to our time. So we'll just say I want to do a perimeter, we'll do some holes. And then we'll tell SOLIDWORKS CAM to go find the features that are on the part. And what it does is it looks at the geometry of the part. So if this was imported or a neutral file format, we would still go through and find the features. We've automatically looked at the database and we found the necessary tools that go with it, and we generated the tool paths. So the last thing we'll take a look at here is we're going to go through and we'll define, okay, we have these fixtures that we're going to use. I can set to avoid these parts in SOLIDWORKS, and it'll automatically adjust the tool paths to avoid collision on any of my vices or fixtures. But I can also come back and do a simulation and see the fixtures as well. So if I come back in here and I run a simulation, I can go ahead and see what the part's gonna look like. We'll go out of turbo mode. I use that for checking my parts when I'm running through my own machine. But if I go through here, I now have tool paths that I can go through and verify how it's going to be machined. And the cool part about this is all this CAM information is stored in the SOLIDWORKS part or assembly file. So when I look at it from a data management standpoint, all of my CAM information except for the output post file is inside the SOLIDWORKS file. So it makes data management easy, it makes PDM easy, it makes sharing the files easy. All of that stuff is just like how you would handle a standard SOLIDWORKS file. The cool part about it also is if this part changes or the design updates, all my tool paths can update accordingly with it. So it's very associative back and forth. The last thing that we'll take a look at here before we jump back over is, let's go ahead and pick a post. We'll go down and select my machine. So I'll just select the Matsura that I have. And when we post out this information, we can put it anywhere we want. I'll drop this on my desktop for here. And when we post it, we end up at the bottom and we have the ability to automatically open up the posted file inside of the SOLIDWORKS CAM NC editor. If any of you guys have used Simco in the past, you'll see that there's a representation or the similarities. We're licensing the technology from Simco, which is one of the best in class post editors or DNC transfer files. I have the ability to do a backplot. So I can go through and verify these toolpaths and backplot and verify that everything works. Consequently, this is how I send information to my old machine through RS-232, so it works really well for data transfer, sending the actual G-code information that's output. So with that, as an overview, we'll jump back into our PowerPoint, and I believe we have another question.
Alrighty, so based on what you've heard, what's your level of interest in SOLIDWORKS CAM? All right. Close. And last one, would you like any further information from us? All right. All right, that's it. And I think we have questions now, Mike.
Yep, so we tried to save a little bit of time today for some questions. One thing I do want to mention also is for all the people that are using My SolidWorks, if you go to mysolidworks.com right now, you'll see that there are a handful of videos for SolidWorks CAM Standard, intro videos to help you get up to speed. I believe we have 18 of them up there that just came up in the last couple of weeks. So definitely go ahead and take a look at My SolidWorks to get a little bit more familiarity with what I went through there quickly through the process. So let's go ahead and take a quick look at questions. Expand this box up here a little bit. Lots of questions, that's a good thing. Let's see here. There's a question if the presentation will be available afterwards. Yes. There's a question without contacting sales, how much is SolidWorks CAM professional? It depends upon where you're at in the world as to the price that's given out. Unfortunately, you're going to have to talk to your reseller. I do believe there are some promotions there that are going on right now for that. Why can't I machine assembly as a part? So when you're in part mode, it only works on a single body. So if you were to try to save an assembly as a part and it would be a multi-body, you'll only be able to machine one body of that multi-body part. Does rule-based machining come in CAM standard? Yes, it does. So our technology database or our rules database is in both versions. It's pretty much the same. The only difference between standard and pro are the features that are available to the users. So SolidWorks CAM is not doing true coordinated 3-axis control. No, it does not do simultaneous 3-axis. We do 2.5-axis in a Z level. So if you think about it like a 3D printer, we do the same thing, but instead of adding material, we're removing material. With that said, there are a couple of routines. I've done some curve profiles inside of SolidWorks CAM that behave like 3-axis. Using some of the SolidWorks features we have for creating UV lines inside of on a surface. The questions about the macros, you just go to 3D Content Central and search for John Milbury, and you'll find that there are several macros that we've created for SolidWorks and SolidWorks CAM to automate the manufacturing process. What's your opinion of running CAM as a secondary activity? So here's what I can tell you over my years. I ran an aerospace machine shop for a number of years using CAMWorks, which is what SolidWorks CAM is powered by. And then I also ran a recycling systems company where we used it to run lasers. What I can tell you is through our rules-based machining, if you spend time and you tailor the rules to your needs, you can make that process very automatic. Even in my shop now for my Matsura, I have my feeds and speeds and rules of how I want a machine set up pretty well to where when I run feature recognition on a part, or even if I manually insert features, the rules are applying the correct tooling, the correct feeds and speeds, depth of cut, lead in, lead out, all of that stuff is automatic. So it just takes a little bit of time of going through and teaching the system how you want to do it. But yeah, you can definitely make it more of a secondary operation. The question about G54 on a solid, that was something that we have in our Vice setup. So we created a visual aid of a part that has the 54, and then we made it and move it around. That works for our drawings to make it easy. Question about software tool libraries. So the tool library is there by default. There's a few hundred tools that get put in the database by default. They are not all the high-end tools. They are very standard for everyone to use, but you can create and customize and add as many as you want or remove what you want. But we do give you a start of tooling that works with it. A question about full 3-axis, full 4-axis, or 5-axis, all simultaneous. When are we going to get those? Right now, our focus is on 2.5-axis. Obviously, we listen to our customers, so if there are things that you would like to see in the product going forward, please add enhancement requests to us. Just like SOLIDWORKS CAD, all of our future plans and development are based upon customer requests and what they want to see in the products. SOLIDWORKS CAM support wire EDM? No, it does not. So wire EDM, obviously we have lots of partners in our partner program that do wire EDM. CamWorks has wire EDM. I know that a lot of the other CAM companies have that. So you would want to look at them to do true wire EDM profiles. Can you adjust helix angles, depth of cut, feeds, and speeds? Absolutely. It's 100% customizable. You can adjust that stuff however you want. What you saw today for tool paths were based upon things that I have set up. I have a Tormach 1100. Which post processor should I use? You would want to contact your reseller. We have Tormachs that we use also, one in our fab lab, and then John has one in his shop. They're very Fanuc based from a control standpoint. There are also resellers like Hawkridge Systems that have posts on their website that are free for people to download as well. But I would definitely talk to your reseller or go to places like Hawkridge and look at their posts that they have online to share with the world. So there's a question about if I create content in 2018, can someone open it in 2017? The answer to that is it's based upon the rules of SOLIDWORKS and backwards compatibility. So anything that you migrate forward, it becomes a little bit of a challenge to go backwards in versions. But I would keep those separate between versions so you don't mess up anything that you're doing in a production environment. There's a question about what do you need to do full 5-axis machining. For full 5-axis machining, you would definitely want to look at our partners. There is an integration with CamWorks from SOLIDWORKS CAM to CamWorks because it's powered by that technology. But depending upon your specific needs for 5-axis machining, you may find that some of our other 40 CAM partners may fit what you need. When you get to 5-axis, in my experience, it is very specific to the type of problem you're going to solve. And certain CAM systems are very good at solving certain components. For example, like Delmia does a really good job of very high-end calculations, as an example. So if you're doing very complex, intricate stuff from a 3D scan model that needs to be in 5-axis for stone architecture, as an example, Delmia processing does a great job with that functionality. So I would recommend that anyone looking for 3, 4, 5-axis capability, definitely look at our partner program and look at the partners that we have, because there are some amazing ones out there that do really cool things for specific machining environments. Lots of questions. This is really good. Let me see a couple more here, and then we'll have to end this. When you simulate toolpaths, does it create an in-process workpiece so you can see your stock condition at every operation? So there's a couple things that we're working on in that. What I can tell you is, yes, you can save STL as an in-process, and you can use that as stock in a future version. It just depends upon how you're looking at it. We also have the ability to tell it when it does simulation to simulate down to a certain point, if you will, or jump to you can say, I want to go to the next operation. It'll just show you the results so you can see through the process. I know some CAM systems do it a little bit different than we do. We are definitely looking at different options for the future and enhancements. Let's see. Some of these are repeats. Did you say standard only mills 2.5? That does not drill 2.5? No, drilling and tapping and threading and thread milling, all of that stuff is in SOLIDWORKS CAM. Anything to do 2.5 axis type work is in there. Drilling is obviously a 2.5 axis feature because generally you're not moving X or Y when you're doing a drill. We do support thread milling if you want to do thread milling. For example, Tormach machines have a lower horsepower, so thread milling is advised over tapping. We've been running that on our machines that we have around the company, and it works great for that. So there's a question about a machine building shop. We don't do a lot of contract machining. When I built recycling equipment, all of our stuff was, we had standard components that we did every time, we had custom components we did every time. We had a mix and match of those, and SOLIDWORKS CAM actually worked really well for that stuff. Because once you have your rules set up and you're 80% of how you're gonna machine anything, what you're gonna machine doesn't really matter. It's the tool paths and how you're gonna approach it, right? Because it comes down to the feature level and the steps you're gonna take to finish that. So it does work really well for that. There's a question of, is CamWorks different from SOLIDWORKS CAM 2018? What I can tell you is, in software development terms, obviously newer versions have lots more functionality and capability. I would definitely recommend looking at the newest versions of any software you're going to use, because there are generally lots of user enhancement requests that make your lives easier. There's some questions on cutter comp. I would have to take that offline because I could talk for hours on cutter comp and strategies, and I don't want to waste everyone's time just rambling on about those kinds of things. Material database, we have hundreds of materials that are in the database if you want to use the feeds and speed library that come with it. You can do feeds and speeds from the library based upon horsepower, radial depth of cut, and diameter of end mill, or you can set it up to use tooling specified manufacturers. For example, my tools are Kennametal, so I use the Kennametal feeds and speeds, and I have those stored in my database. So when I grab my 3/4 inch 2-flute high profile, high helix end mill, I'm running at the speeds from Kennametal, not the speeds from the material library. So you can set it up in different ways. SOLIDWORKS CAM, we do have the SOLIDWORKS CAM Standard Essentials class. We have books that are created for that. We're working on one for Pro, but just like SOLIDWORKS CAD, if you go through an Essentials class for CAM Standard, being able to use CAM Pro is easy because we're just turning on some features. So once you learn the basis, just like you would in SOLIDWORKS, you can use any of the advanced features fairly easily. There are several post-processors included. They are generic post-processors. You can also, if you're a post-processor person, we have an application you can download from CamWorks called the UPG, and that allows you to make adjustments. So like for example, if I had a Haas post that comes with the software and I don't want to see line numbers, I can use the UPG to remove line numbers from my post or do any formatting changes and repost it and have my own custom post. Likewise, there are lots of resellers that will also provide that as a service to you if you don't want to get into posting. Some people like that challenge, some people don't. So it really just depends upon how you want to work, but we do have standard ones. There is the UPG to create custom or create unique formatting ones, and then there's also resellers that can help you with that. For Essentials class training, definitely talk to your reseller. There should be standard classes that all of the resellers are holding. They all have access to sell and provide support for this product worldwide. Can custom tool geometry be reported into the CamWorks version? Yes, you can do custom tools in SolidWorks CAM and CamWorks. With that, I think we'll go ahead and jump off here. We're about 30 minutes. If there are any questions that do come in later, you can send them to the email and we'll try to get them answered offline. And then we'll go from there.
All right. Thanks, everybody, and have a great day.
Thank you.